We will now proceed with the next section, which is about vectors. Vectors are like arrays that can change size as your program runs, which means vectors are more flexible as compared with a typical array in terms of efficiency and ease of use. Vectors, like arrays, have a base type. If we would like to declare an empty vector with a base type of integer, we can simply do the following, thus giving us a vector of integers. This identifies vector as a template class. If you will notice, this is quite different from the typical variable declaration that we do. You can use any base type in a template class, such as this one. We have a vector of strings. Now, how do we access vector elements? Vector elements are indexed starting with 0, just like your arrays. The brackets are used to read or change the value of an item. For instance, we can assign the following index location with the value 42, and we can also display its output by referring to its index number. Brackets cannot be used to initialize a vector element. Therefore, how do we initialize vector elements? Elements are added to a vector using the member function pushback. The function pushback adds an element in the next available position. This is quite different from the way we insert elements to an array. Here's an example. For instance, we declared a vector of double named sample. If we would like to insert value into our vector, we simply call the pushback function, such as this one. Now let's talk about the size of a vector. The member function size returns the number of elements in a vector. For example, we can print each element of a vector given the previous vector initialization. We have the following example of a loop, which outputs the contents of a vector, given an element number based on the loop. Talking about the type unsigned integer, the vector class member function size returns an unsigned integer. Of course, unsigned integers are non-negative numbers. Some compilers will give a warning if the previous for loop is not changed to the following form. In this case, we implicitly specified unsigned integer as the data type for our counter variable, which will then be used to access the element number inside our vector. We also have an alternate vector initialization. A vector constructor exists that takes an integer argument and initializes that number of elements. Here's an example. What it does is it initializes the first 10 elements to 0, which is the size of the vector, which would return 10. Brackets can now be used to assign elements 0 through 9. And pushback is used to assign elements which are greater than 9. So how do we initialize vector with classes? The vector constructor with an integer argument initializes elements of number types to 0. It also initializes elements of class types using the default constructor for the class. And we also have the vector library. To use the vector class, we need to include the following include directive. As we can see here, we simply include the vector library. Vector names are placed in the standard namespace, so the usual using directive is needed. Let's take a look at this example. Here's a program which demonstrates the use of vectors. As you can see here, we need to include the vector library in order for us to use all the functionalities of a vector. And here's our program body. Of course, we initialize and declare a vector variable. And in this case, it will require us to input a list of positive numbers. And of course, the moment that we enter a negative number, that will be the end of user input. And of course, it will simply return the numbers that we have entered. Let's give it a try. And just like that. As you can see, the process of inserting new elements into an vector is more efficient and, shall we say, it's more straightforward as compared with a regular array in which we are limited with the predefined size of an array. As compared with a vector, we can actually change its size even at runtime. However, there are also a few issues with the use of vectors. For instance, attempting to use brackets to set a value beyond the size of a vector may not generate an error. If that's the case, that can be a problem to our programs. In this case, the program will probably misbehave due to a logical error. The assignment operator with vectors does an element by element copy of the right-hand vector. For class types, the assignment operator must make independent copies. How about the efficiency of a vector? A vector's capacity is the number of elements allocated in memory. Thus, it is accessible using the capacity member function. Size refers to the number of elements initialized. Of course, a vector can be resized dynamically. When a vector runs out of space, the capacity is automatically increased. A common scheme is to double the size of a vector. Therefore, it is more efficient than allocating smaller chunks of memory, thus assuring us that our vector always has the enough capacity to accommodate new elements. So how do we control vector capacity? When efficiency is an issue, member function reserve can increase the capacity of a vector. Here's an example. In this case, we would like to reserve at least 32 elements for our vector. And also, should space run out, we can simply resize our vector to accommodate more elements, such as this example. For similar purpose, resize can be used to shrink a vector. Here's an example. For instance, we would like to shrink the capacity of our vector to 24. Thus, we simply call the resize function which would shrink our vector. However, as a result, elements beyond 24 will be lost. Thus, these should be used with caution. That's all for vectors. In this section, we were able to declare and initialize a vector of varying capacity. We can also write code to increase the size of a vector, and as what we have seen, we can simply use the function reserve. And of course, we can also shrink the capacity of our vector using the resize function.